Part C, we have definite integral from 0 to 1, 10 times e to the 2x. 10 is a constant multiple, lower limit 0, upper limit 1. So 10 integral 0 to 1 e to the 2x with respect to x. Again, think backward. Think backward. What function that its derivative is e to the 2x? Supposed to be the same form of the e, right? The e to the power. But we have to make sure that when you find the derivative, it gets back to the same as e to the 2x. And recall the rule from 4.9. When you find the integral of e to the power u with respect to x, you're going to have e to the u, and then what happens? That's actually it's in the form. Let me rewrite in the form that easy to apply. So integral of e to the power kx with respect to x is e to the kx and divided by k. Why divided by k? Because when you check the result, because this is the antiderivative, that means when you find the derivative of e to the kx over k with respect to x, you're going to get 1 over k multiplied by k e to the kx. So k and k reduce, and it gets back to the just plain e to the power kx. So that's why it's called think backwards. So backward chain rule for now. If you go forward to find the derivative, you would have multiplied by k, which is the derivative of the inner function, but you don't multiply, you're going to divide when you find the antiderivative. Okay, for our case, the k equals 2. Then when we apply, we're going to get e to the 2x and divided by 2. If you are not sure, again, find the derivative of e to the 2x divided by 2. You're going to get 1 half e to the 2x, and that returns e to multiply by 2, sorry. So 2 and 2 reduced, we get back to e to the 2x. So this part is the checking part. So we get the right antiderivative. And this is a definite integral. You don't add c because you are going to use the number, the lower limit. This is the variable x going to be from the lower limit x equals 0 to the upper limit x equals 1. Simplify 10 and 2 reduce to be 5. So 5 as a coefficient, I try to factor 5 out. Just work on the subtraction of the e to the power for each lower and upper limit. Okay, so the first part is from the use of the upper limit. Upper limit is 1, so e to the 2 times 1 minus e to the 2 times 0. E to the power 0 is 1, not 0. Okay, be careful. And e to the 2 times 2 is just e to the second. So now we have 5 multiplied by e to the second minus 1. And this is called the exact form of the solution. If the problem on my MATLAB asks you to read the answer as the exact form, this is what we are looking for. If you use a calculator or some fancy calculator that can give you the value out, you will get like what the decimal number that is not acceptable. Okay, so you have to leave it as the exact form and show your work to earn more credits or earn the partial credits. So this is part C when we were involved with the exponential form. The main part is find the right antiderivative, and the second part use algebra to simplify the numbers, and the answer will be some form of the real number. Okay, let's move on then for the last example. We're gonna evaluate, this time is a trig function. Lower limit pi over 16, upper limit pi over 8, integrand 8 times cosecant square of 4x with respect to x. Get 8 out as the constant multiple or the coefficient, and then work on the antiderivative of the cosecant squared of 4x with respect to x. Think backwards. What trig function that its derivative is cosecant squared? Could anyone let me know what would that be, that function that its derivative is in the term of cosecant squared? Oh, thank you, Jeff. So the tangent is close, is close. The tangent x, excuse me, derivative of the tangent is secant squared. Think about another group of the trig function. If it's not the tangent, what else that we have as the leftover choices? Not sine, cosine, right? If you could get out the derivative rules from chapter 3, 3, 4, 3, 5, those kind of sections, that would be helpful. Or you look at the 4.9, the 4.9 will have the set of the antiderivative rules. As long as you recognize it or you know what it is, it's going to help you take care of the problem in a less complicated way. If you don't know where to go, I can help you with that. We can work one-on-one outside of the class. So if not tangent, what would that be? We have 6 of them, right? We have sine, cosine, definitely not sine, cosine. Now it's not tangent and secant. So what would that be? The one that we did not use yet. Is cotangent. Okay, so the derivative of the cotangent x is negative because begin with the c, negative cosecant square x. That means the antiderivative of the cosecant square is negative cotangent x, but it involving the composite function. If composite function, what does it mean? It means you're gonna do the backward chain rule. Okay, we're gonna do the backward chain rule. So this is the on the side note the prep. Now we have 8 backward chain rule. So with negative, apply the main part for the the cosecant squared is negative cotangent of the same argument for x. And then since the inner function is 4x, the derivative is 4. You don't multiply, you're gonna divide by the derivative of the inner function. Now we get the antiderivative of the cosecant square of the 4x. When we get the antiderivative, the integral sign gone. The integral sign is in the front. After you get antiderivative, it will be gone, okay? And then put the bar in the back. This is involving the variable x, so x equals pi over 16 as a lower limit, x equals pi over 8 as the upper limit. Simplify before we replace that number. So this is 4. So 8 and 4 reduce to be 2 with a negative sign. So I will put like negative 2 as, I'll treat negative 2 as a coefficient. And then we write it as the cotangent of 4x. Evaluate from pi over 16 to pi over 8. And then negative 2 out front. First round, replace x with the pi over 8. So we have cotangent of 4 times pi over 8 minus the cotangent of 4 times pi over 16. Okay, the 4 times pi over 8 reduced to be pi over 2. And the second term reduced to be pi over 4. And on the side note, let's see what is the cosine of, or what is the cotangent of pi over 2. Cotangent is what two functions that form the cotangent function?
Let's see, cosine divided by the sine.
Thank you. Thank you. That's correct. So cosine pi over 2 divided by sine pi over 2. With this way, it might be easier to think about the value that we're going to use in a problem. So what is cosine at pi over 2? What is cosine at 90 degrees? You can use the unit circle to think about it. 90 degrees is on the y-axis. What the order pair there? We get 1 comma 0, no 0 comma 1, sorry, 0 comma 1. The 0 is the cosine, the 1 is the sine. So at the angle pi over 2, the cosine is 0, the sine is 1, so the cotangent is 0. Similar way, the cotangent of pi over 4 is from the cosine pi over 4 divided by sine pi over 4. Pi over 4 means 45 degrees. That's the same, right? So the cosine of 45 degrees is the same as sine 45 degrees. That means the cotangent 45 degrees is 1. Okay? Now, we have those two numbers. Bring it to the problem, which is negative 2 multiplied by 0 minus 1. And the result is positive 2 for this definite integral.